Page 32. Okay, page 32. I'm going to try to make this as painless as possible. Okay, page 32. So what I'm going to do today is I'm going to highlight every time I see a complementary angle. I'm going to highlight that orange. You choose whatever you want to choose for that. And every time I see a supplementary angle, I'm going to highlight that in pink. That's what I'm going to do, just to make it stick out. Let's remind ourselves, what are complementary angles? They add up to 90. It's right to complement someone. Think about it that way. It's right to complement. So complementary, you have something like that going on. Supplementary, yeah, it's like you can call it a Mexican hat or a cowboy hat, or you can call it I don't know, a soup bowl, I don't know, flying saucer, whatever you want to call it, but that's supplementary. Supplementary. So guys, this is not like really solving why sine law, cosine law. We've done it all. We know now how to use sine law, cosine law for the most part. This is now just getting information inside the triangle. Okay, so here's my highlighting part. Different highlighter, please. So angles that are outside the triangle, we are going to find a way to get it inside the triangle. So when things appear to be missing, it's just really a step away from finding more information and getting some information inside that triangle. So a lot of these are like navigation. When you navigate, like when you're on the ocean, right? Or you're going through the forest and you're using a compass to adjust your course. Because only in those scenarios can you like go straight, right? In the city and whatever, we always have to like turn and follow the streets. Planes will be using this as well. But anyways, the captain of a boat sees 2 points of land. Point C is 1.8 kilometers east of the boat. So watch this, the boat is here, 1.8 kilometers east of the boat is right here. So diagram is provided, it's just giving context around it. And point A is at a bearing of 12 degrees. Anybody heard of that before, bearings? Now, bearings go like this, guys. This is your north, south, east, west. Remember, it has to spell we, not you. And so this would be a 0 bearing, and this would be a 90 bearing, 180 bearing, 270, and then back to 360, right? So it goes all around like that. So if you go at a bearing of 90 degrees, you're essentially going east. We are now told that we're going at a bearing of 12. So it's measured from the north, 12 degrees this way. So look at this triangle. 2 sides, that's all. We need an angle inside. So do you see a type of angle, one of these two in this scenario? You see the east line meets the north line. That's a complementary, right? So let's do this. It's like, hey, at this corner, I know it's 90 between the oranges. Anyways, orange sides, okay? So what could I do to figure out this angle in here? Because I know that this little sliver, it doesn't matter where you do this, guys. It really doesn't, but it's 12 degrees. This measures from this side to this side, it's 12 degrees. So how would I find this one? Angle B is 90, because that's the whole thing, minus 12 degrees. That's it. Right? 90 minus 12 degrees. Angle B is 78. Oh, I don't have my 78 degrees. Complementary, right? Complementary angles. So now I'm going to use a red pen or something, and I'm going to write in the 78 degrees. What do I use to start this, guys? What law will I use to solve? What is it even asking for? How far is the boat from point A? How far is the point? It's like the boat from point A. So they're asking for this side right here. This is my question mark right here. How would I do that? What law am I going to use? Like a British accent. I'm trying. I'm not really good at it. What law would I use? Oh, they won't like that, so I shouldn't do it. Just stick to my own. Yeah. So here we go. That's a pair, right? You start with it. Let's start with it. So sine of 78 over 2.5 kilometers. Boom, boom, boom. Can I solve for the side in question at the moment? Look at the side. Look at the angle across. Both unknown, right? So no go. No go. This is a two-step question. But I do know the 1.8. So I'm going to put that down here. And this is going to be A, right? Just like that. Because that's just so much easier, Mr. Dirksen. I'm just going to do A. I don't like sine. You have to, right? Sine of angle, which means you're going to have to use the inverse at one point, right? So sine of A is cross multiply and divide. So 1.8 times sine of 78 over 2.5. And last step is angle in question is going to be sine inverse. And because of time, I'm going to go and just give you what this should be. There you have it. Angle A ends up being 44.77 degrees. Not the final answer, but important. Important. So I'm going to box this in, kind of say, hey, this was necessary to get me closer to my answer. So this was step number 1. Get an angle on the inside of the triangle. Step number 2, solve for whatever can be solved, which in this case was angle A. And what's my next step? Third step. I have this angle, I have that angle. I can now find angle C, correct? Sum of triangle. Angle C is 180 minus 78 minus 44.77. Angle C is 57.23. Also important. So, Mr. Dirksen, are we solving a triangle? Basically. In this case, you are basically solving a triangle. Can we, how about this? I'm just going to say, hey, this angle right here is the one you needed to make this thing work, right? The 57.23. So we're combining everything we know about working with triangles here. We're combining complementary angles. Boom. Sine law. Boom. Sum of triangle, right? Sum of triangles equal to 180. That's also a concept, right? And now we're going to use sine law again. Mr. Dirksen, could I use cosine law? Because side, angle, side. Let's do it. Let's do it. So we're going to call that lowercase c. Lowercase c squared, so this is c, is going to be 1.8 squared, this side, plus 2.5 squared, minus 2 times 1.8 times 2.5 times cosine of 57.23. I used sine law in my original, but it doesn't matter, provided you do everything right. 1.8 squared plus 2.5 squared minus 2 times 1.8 times 2.5 times cosine of 5723. That's 4.618 dot dot dot. And what must happen next is you need to root it. 2.15, which is exactly what I got using sine law. That is your final answer. That is what the question was ultimately after. Are all test questions going to be like that? No. There's going to be like maybe one or two that are this long. Okay? So don't be like, oh my goodness, is it going to be like this every time? No. Most of them are going to be the way the AC was just now. Just one step. Okay? I'm going to run out of time, but I'm going to ask you to do this anyways because you have a super long weekend. Okay? So because I'm miserable having to come in tomorrow, I'm going to make your lives. No, I'm just kidding. I'm just kidding. Can I just take you to page 33 real quick? I know you can do this. Like, I believe in you guys. I truly believe in you guys. Go to page 33. What do you think you're going to have to use there? Complementary or supplementary? This is my triangle. Does this look like a 90 here somehow? No. It looks like a supplementary, doesn't it? What did I use for supplementary? I used pink. So I'm just going to kind of give it away here. Supplementary angle right there. Is there a way to use that 20 to get me an angle inside the triangle? The answer is yes. Right? But this is the curveball here. I don't want this to be a hurdle. I really don't. If a ship travels for 2 hours at 35 kilometers per hour, how far will it have traveled in total? 2 hours times 3570, right? Just turn that into 70 kilometers, and now you have a side length. Okay, and then you have 3 hours at the same speed. So you continue 3 hours. You go 3 hours times 35, and what's that? Another 35, right? Because it's 3 hours, so that'd be 105 kilometers. Put those numbers in for your side lengths here, and then try to solve this, and I'll give you the answer. The answer is supposed to be 172.45. This one is not as long, by the way. So I want you to try, I'm just going to say 33 to 35. I don't assign homework a whole lot, but I need you to, we're getting closer to the end of this unit. I need you to try those. It's not extremely long. I will post the answer key. I probably will post more than what I assign, just because it's like one big file. So you just go look up these pages and go to town. Okay. If I can, I'm not going to record this because then that's a promise that I